about how to set these up. So the first lesson that we did together, this was the 5.10 notes. And then this is what we're going to learn for these notes. Okay, so the only thing that's going to be extra is once you guys figure out your equation to optimize, you have to find the max or min. So that means you must set the derivative equal to 0 and solve. Okay, then if you have more than one answer, you have to first make sure that it's a max or a min if it meets that criteria. Determine the domain endpoints of your equation to verify if the endpoints represent a max or a min. We'll talk about that. This sounds more complicated than it actually is. All right, so the first problem we're going to do is we actually already know what the equation is for this problem. This is the same problem that we have from the first notes. So to find the distance, the closest distance from this point to this curve, we're basically finding a minimum. So if you guys look at the notes from Tuesday, can you guys tell me if this is what you guys have? D is equal to the square root of x minus 5 squared plus x. So we need to find the minimum, we need to take the derivative and set it equal to 0 and solve. So what I'm going to do is I'm going to actually clean this up a little bit before I take the derivative. So what I'm going to do is I'm going to expand this. So x minus 5 times x minus 5, and then add x. So if I do that, thank you, you would get x squared minus 10x plus 25, and then add x. So if I do that and combine like terms, you're going to get the square root of x squared. Negative 10x plus x gives me negative 9x plus 25, okay? Everyone cool with that? All right. So what I'm going to do, and I apologize, guys, just write a little bit small just so everything fits. The derivative, you guys agree I could just abbreviate as d prime? It's going to be, I need to do the chain rule. So do you guys remember that the derivative of square root of x, isn't it just 1 over 2 root x? So I need to do the chain rule for this because on the inside, I don't have x, I have all this. So the derivative is going to be on the bottom, I'm going to have 2 square root of the inside. So the derivative of the outside at the inside. So it's going to be x squared minus 9x plus 25. And then times the derivative of the inside. What's the derivative of the inside? 2x minus 9. Okay. What's nice about this is the derivative equals 0 only when the top equals 0. Do you guys agree that whatever this is going to be when it's undefined? If it's undefined in this case, we don't really care because that's not going to represent a max or a min. Do you guys see what I'm saying? So you only care about when the top equals 0 because you're trying to figure out when the derivative equals 0. So set this equal to 0. So 2x minus 9 is equal to 0. And if I solve that, I'm going to get 9 over 2. So this is the x coordinate. I want the point that's closest. So the x value is going to be 9 over 2. Do you guys agree that to find the y value, I could take this number and plug it into the equation? So the point that we're talking about is going to be 9 over 2, comma, if I plug this in, the square root of 9 is 3 over the square root of 2. And remember, in calculus, we don't care about radicals on the bottom. You can just leave it like that. Okay. Questions? No? All right. Problem number 2. Hey, this looks familiar too. We already have the function that we want to optimize. We just need to take the derivative. So if you guys look back at your notes from Tuesday, the function that we want to optimize, write a little bit small, guys. W was equal to the square root of 28 squared plus 30 minus x squared plus the square root of 12 squared plus x squared. If this bothers you, you can figure out what this is. You can figure out what this is, but this is going to be a calculator problem. You guys will see why. When I take the derivative of this, I need to do the chain rule twice. All right, so don't be shy, guys. If you guys get lost, just tell me. This is a square root, right? So the derivative of the outside at the inside is going to be, on the bottom, I'm going to have 2 square root of what's on the inside, 28 squared plus 30 minus x squared. The derivative of the inside. What's the derivative of this? 0. The derivative of this, I also have to use chain rule. So bring the power down. So it's going to be 2 times the derivative, or times the inside, times the derivative of the inside. What's the derivative of the inside? -1. Okay, plus, same idea. I need to do the derivative of this. So it's going to be, on the bottom, I'm going to have 2 square root of 12 squared plus x squared. And then what's the derivative of the inside? 2x. Okay. Now, this is my derivative. I can clean this up if I want to. Do you guys see how I have a 2 on top and a 2 on the bottom? Can't I cancel those? And then I have a 2 on top and a 2 on the bottom here, so I can cancel those. So W prime is equal to 30. Actually, I can even clean this up even more if I wanted to. -1 times 30 is -30. Negative x times -1 is plus x. All over the square root of 28 squared plus 30 minus x squared plus x over the square root of 12 squared plus x squared. And I want to try to figure out when this is equal to 0. Okay, so here is what would be a smart thing to do. If I want to solve this instead of equal to 0, do you guys agree that the algebra here would be awful? Because I would have to get a common denominator, and that's going to be terrible. So what I would do is, we already have our derivative. Why don't we graph this? And if we're trying to figure out when it equals 0, you're trying to figure out when this crosses the x-axis. Okay? So what I want you guys to do with your calculators, type this into y1 and then hit graph. Good? Yeah. Morning. The next part of this. Okay, so if we go to graph, does you guys' function look something like that? So if I want to try to figure out the 0, I'm going to do second, trace, 0. Oh, I want to show you guys something cool that I saw on YouTube. You know how usually like we scroll for left bound, right bound? Do you guys see how we know for sure it looks like it crosses maybe like 1, 2, 3, 4, 5, 6, 7, 8, maybe like somewhere between 7 and 8. Do you guys see that? So for left bound, do you guys agree like 0 for sure is to the left of that value? You can just hit 0 and hit enter. And do you guys agree that 10 is somewhere over here? If for sure crosses between 0 and 10, you can just type in 10 and hit enter. And that means it's going to find the 0 between those. So that's a shortcut you guys can do instead of scroll, enter, scroll. You don't have to do that. And then hit guess, and it crosses at 9. So the X value that this crosses at is 9. So if you guys want to get fancy, we know that these towers are 30 feet apart, right? If we go back to our picture from Tuesday, if I plug in 9, do you guys agree that the stake would be 9 feet away from tower 2? What's 30 minus 9? 21. So, and the stake would be 21 feet away from tower 1, if you guys want to get fancy with your answer. So 21 feet from tower 1, 9 feet from tower 2. All right. All right, last example, and then you guys will have a lot of practice time today. A particle is traveling along the x-axis, and its position from the origin can be modeled by x of t is equal to t cubed minus 15t squared plus 72t minus 9, where x is in centimeters and t is in seconds. I'm going to highlight that because we'll need that for our answers. On the interval, t is between 3 and 9. Find when the particle is farthest to the right. So a couple things. It wants us to find when. So that means find the time, find t, when the particle is farthest to the right. Now, just thinking logically, guys, we're talking about maxes and mins, right? If a particle is traveling along the x-axis, if it's farthest to the right, what does that sound like in our context? A maximum, right? Because farthest to the right would be big. So this is asking you to find the max. Okay? So what's nice about this one is we don't have to come up with an equation, we already have it. So when define the maximum, what do we need to do with this function first? Take the derivative. So if this is the position function, do you guys agree that the derivative of this would be? What's the derivative of position? Velocity. So I could call it v of t is going to equal, the derivative of this is going to be what? 3t squared minus, you guys tell me, minus 30t plus 72. Okay, I want to figure out when this equals 0. So before I jump straight to quadratic formula, I notice that all these numbers are divisible by what? 3. So factor out a 3. And we're going to get t squared minus 10t plus 24. What are the zeros? Yeah, t minus 6, t minus 4, so that means t is equal to 4, and t is equal to 6. Okay, question. We have an interval, right? Are these numbers inside my interval? If it's not, then what do we do? Do we need to plug them in if they're not in the interval? No. So save yourself some time. If, like, let's say we got t is equal to 11. 11's not between 3 and 9, so you can just cross that value out. Okay. So some of you guys were asking this on Monday when you guys did your little almost said scavenger hunt, the circuit training. When do you do the candidates test? When you guys make the table? When you have an interval, that's when you do the table. Okay. Which function do I plug it into? Which one? The original. So you're going to plug it into this one. Okay. So plug in the endpoints. So we need to find x of 3, x of 4, x of 6, and x of 9. Okay. I'm really excited to show you guys this because this is something I didn't even know you guys could do. We have a calculator. So this is the shortcut way to do this on your calculator. Okay, so this is what you guys are gonna do. You guys ready? So purposely, I don't want you to clear Y1. I want you guys to leave that there on purpose. Okay, scroll down to Y2, and I want you guys to type in that function. So help me out, guys. What was it? X cubed, 15x squared, minus 9. Okay. So we're going to plug values into this, right? So do you guys remember that your calculator has a table feature? So what I want you guys to do is I want you guys to go to second and then table. And notice that it gives me, this is for the first function, right? We care about the red one. So let's say that you don't want to get confused and pick the wrong answers, but you still want to save this function because that first function was annoying to type in, right? If for whatever reason you have a situation where you still need it later and you don't want to clear it, go back to Y1. If I don't want the table to show that, do you guys see how the equal sign is highlighted? Use your arrows, hover over the equal sign and hit enter. So do you guys see how it's not bolded anymore? If I go back to my table, check it out. It's not there anymore. So it's like it's kind of hidden for now. If I graph it, same thing. It's not there anymore. But if I want it to come back, all I have to do is go over here, highlight it again, and then it's back. Okay? So that's important to understand that you could do that. Okay. Now here's the other important thing. Let's say we had to plug in, these numbers aren't very big, right? But let's say we had to plug in like 0, and we had to plug in 10, 150. Are these numbers all those numbers all close together? No. So what you could do is go to your table settings. So second, table settings. Where it says independent, where it says auto or ask, go down and change it so it says ask. Because what that does is if you go back to your table, you can tell your calculator which values to plug in. Okay, so what values do we want to plug in? 3, so hit 3, enter. 4, 6, and 9. And boom, those are our 4 answers. I didn't even know you could do that. I figured that out on YouTube, and I thought that was really cool, and I was really excited to show you guys that. All right, so going back to our problem. So we got 99, 103, 99 again, and 153. So if we're trying to figure out when it's farthest to the right, which of those values is largest? The 153, right? So because the question says find when, remember this means time. So the answer to this question is it's farthest right at t is equal to 9 seconds. Okay, this is being recorded right now, so if you guys want to see that calculator trick again, you guys can watch the video on YouTube, or you guys can always come ask me. Don't be shy. All right, last part. On the same interval, find the particle's maximum speed. So we're trying to find another max. So do you guys agree that this is the velocity function? So the maximum speed, remember, do you guys remember what speed is equal to? Good. It's the absolute value of velocity. So what we need to do is we need to find the max of this function. So how do you find the max of this function? What do you do with it? Take the derivative again. So v prime of t is going to equal 6t minus 30. Set it equal to 0. So 0 is equal to 6t minus 30. And if we solve that, we get t is equal to 5. So we're using the same interval. So is this value, guys, is that between my endpoints? So that means I'm going to plug in. Since we're finding the maximum speed, I need to plug it into the velocity function. So I need to find v of 3, v of 5. I need to find v of 9. Okay, I want you guys to do the same thing. So go to your calculator, type in the velocity function into another y value. It's going to go down to y3. So 3x squared minus 30x plus 72. Okay. If you guys don't want to get confused, you guys can go up here to the y2 and hide it so it doesn't show up. Go back to your table, and then you guys can just hit clear. I think delete. You can't? Oh, delete. If you hit delete, the delete key by the mode, it will delete the values. So we want 3, we want 5, and we want 9. So even if it's negative, remember, we still want to write it down. So 9, negative 3, and 45. So which of those, ignoring the sign, guys, which of those is biggest? 45, right? So the maximum speed is 45 what? What's our units? Yes, centimeters per second.